victog.com.
So we are going to prove basic proportionality theorem. That means the short form is BPT. In other name, it is also known as in another name, that means Thales theorem. Thales theorem or BPT, basic proportionality theorem. Thales theorem. Basic proportionality theorem, BPT. The statement is also very important because sometimes for the exam they will not give the statement. They will ask the question like this: state and prove Thales theorem, or state and prove basic proportionality theorem. So in such a case you have to write the statement of the theorem also. So study very well the statement also. The statement is, if a line is drawn parallel to, if a line is drawn parallel to one side of a triangle, to intersect the other two sides, are divided in the same ratio, to intersect the other two sides in distinct points. If a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points, the other two sides are divided in the same ratio. The other two sides are divided in the same ratio, This is the statement of the theorem. You have to study this statement of the theorem also very well. The figure is, there is a triangle ABC. This triangle ABC, a line is drawn parallel. DE is parallel to. This line segment DE is parallel to BC. Then we have to prove that AD by DB is equal to AE by EC. This is the thing which we have to prove. Given that DE parallel to BC. We have to prove that AD by DB is equal to AE by EC. For that, we have to do some constructions. That means, draw a perpendicular from D to the side AC. Perpendicular, it is M. And draw a perpendicular from E to the side AB. Here it is 90 degree. This is the point N. And join BE. And DC. These are the two constructions. Construction. Draw DM perpendicular to AC. Draw DM perpendicular to AC and EN perpendicular to AB. Now join BE and CD. These are the constructions. Now we are going to finding the area of triangle ADE. We are going to find out the area of triangle ADE. Area of triangle ADE. The usual formula, we are using the usual formula, half BH. Area of triangle ADE is equal to half BH. Here we are taking the base as AD. In triangle ADE, we are taking AD as the base to find out the area of triangle ADE. Half into AD into altitude. Altitude is EN. EN is the altitude. Half into AD into EN is the area of triangle ADE. Now we are going to find out the area of triangle BDE. Area of triangle BDE. Area of triangle BDE is equal to half into. Here we are taking BD as the base, half into BD into, what is its altitude? The side BD is taken as the base. So the vertex opposite to the side BD is C. We have to take the perpendicular from this vertex C to the base BD. But it is not possible to draw a perpendicular from C to the side BD. So we are taking that perpendicular as, this is the side BD and the opposite vertex is E. BDE, we are finding the area of triangle BDE, and the vertex E is the vertex which is opposite to side BD. We have to draw a perpendicular E to the side BD, which is impossible because BDE is an obtuse angled triangle. As BDE as an obtuse angled triangle, we can't draw an altitude, that means a perpendicular from the vertex E to the side BD. So we will take the perpendicular which is drawn to the line segment AB, which is an extension of the side BD. BD is extended to the vertex A, and we have to take EN as the perpendicular or the altitude of triangle BDE. So area of triangle BD is equal to half into BD into the altitude is EN itself. EN. So we had to find out the values of area of triangle ADE and the area of triangle BDE. Area of triangle ADE is equal to half into AD into EN. And the area of triangle BDE is equal to half into BD into EN, because we cannot draw a perpendicular or draw an altitude from the vertex E to the side BD, as triangle BDE is an obtuse angled triangle. So we are taking EN as the altitude. Now find the value of area of triangle ADE divided by area of triangle BDE. Area of triangle ADE divided by area of triangle BDE. The result is half into AD into EN. Half into AD into EN divided by half into BD into EN. This half and half get cancelled. Similarly, EN and EN also get cancelled. Now the remaining quantities is area of triangle ADE divided by area of triangle BDE is equal to AD divided by BD. We are getting the result as area of triangle ADE divided by area of triangle BDE is equal to AD divided by BD. AD divided by BD. We are taking this as equation number 1. Again, we are finding the area of triangle ADE. Again, area of triangle ADE. Area of triangle ADE. This is read as area of triangle ADE, which is equal to half into. Here in the second case we are taking or considering AE as the altitude, half into AE into, then the altitude is DM. DM is the altitude, half into AE into DM. Again we are taking the area of triangle DEC. Area of triangle DEC. Area of triangle DEC is equal to half into, here we are taking EC as the base. EC is the base into. Now the vertex opposite to the side EC is B, and the altitude is from the vertex B. We have to draw a perpendicular to the side EC. Here also BEC, triangle BEC, triangle DEC is an obtuse angular triangle. Triangle DEC an obtuse angular triangle, and we cannot draw a perpendicular from D to the side EC. Here also in area of triangle DEC we are taking EC as the base. So the vertex opposite to the side EC is the vertex D, and we cannot draw a perpendicular from D to the side EC. So we are taking DM as the perpendicular, as the altitude, because AC is the extension of the side CE. So we are taking the perpendicular DM as the altitude of triangle DEC, which is equal to DM itself. Area of triangle AD is equal to half into AE into DM, and the area of triangle DEC is equal to half into EC into DM. Now we are finding area of triangle ADE, divided by area of triangle DEC, which is equal to this half and half get cancelled, and DM get cancelled. It will be equal to AE by EC. Half into AE into DM divided by half into EC into DM. This DM and DM cancelling, half and half cancelling. The remaining quantity is AE divided by EC. This is equation number 2. Area of triangle ADE divided by area of triangle DEC is equal to AE by EC. We are noting it as, naming it as equation number 2. Now consider the left side of equation number 1 and 2. LHS of equation number 1 and 2. Area of ADE, numerators are equal, and area of triangle BDE and DEC. Consider the triangles BDE and DEC. BDE and DEC. Triangle BDE and triangle DEC are on the same base. DE, and between the same parallels, DE and BC. Therefore, area of triangle BDE is equal to area of triangle DEC. Therefore, left hand side of equations 1 and 2 are equal. Therefore, from 1 and 2, equations 1 and 2, we get the RHS are also equal. The right hand side RHS are also equal. That is, the RHS of equation number 1 is equal to AD by BD. That is AD by BD, which is equal to RHS of equation number 2 is AE by EC. This was the thing which we have to prove. AD by DB is equal to AE by EC. This is the proof of Thales theorem or basic proportionality theorem. You have to study from the statement itself. It is an important theorem. You have to study very well. First of all, taking area of triangle ADE and area of triangle DBE. Then again finding area of triangle ADE and DEC. Then dividing, we will get AE by EC. We have to prove that area of triangle BDE and DEC are same, because these two triangles are having the same base DE and they lie between the same parallels DE and BC. Therefore, area of triangle DBE and DEC are equal. From that result, we are getting the left hand sides of equation number 1, 1 and 2 are equal. Therefore, the right hand side RHS of equation number 1 and 2 are also equal. That means AD by BD is equal to AE by EC. That is the result which we have to prove. Hence, proved the theorem. Study very well this theorem. It is an important theorem. Okay.